So, if we look at a broad level, what are the components of a suspension system that are used to achieve these functions. So, the first set component are springs. Okay. Springs are nothing but energy absorbing elements, right. So, we get a disturbance or excitation from the road, that energy is absorbed by the spring, right, and then we have dampers or shock absorbers, which essentially ensure that these vibrations are dampened down, right. So, that's an important requirement. So, springs provide compliance, right, dampers, shock absorbers provide energy dissipation. So, there are energy dissipating elements. Okay. Then there are various suspension links, okay, and also other components to provide support to the suspension. Okay. We will look at these components as we go along. Okay. So, broadly like these are the three classes of the suspension components. So, first let us look at springs, okay, which are energy absorbing elements. So, let us look at different categories of suspension springs. Okay. So, the first type of suspension spring that we are going to consider are what are called as leaf springs. So, what are these leaf springs? Okay. So, leaf springs are very popular, like they have been around for quite a long time. So, what does a leaf spring do? Right. So, let us look at this leaf spring, 1 minute. So, this is a simple schematic of a leaf spring. So, what happens in a leaf spring is that there are these metallic leaves, like which one could observe here, right. They are essentially held together by these clips, they are bolted to the axle and held together by a clamp, right, and at the two ends of this leaf spring, like they are fixed to the vehicle body or vehicle frame. So, the leaf of the individual leaves of the leaf springs are curved. So, when they are subjected to load, they are going to deform, and that is going to result in a springing action, right. So, it is very simple in construction, right, and very effective too, So, if we look at leaf spring, so these were one of the earliest types of springs that were used in road vehicles and still being used, right. So, it is constituted, of course, I should say here we are looking at the first category, right, which is a leaf spring, right. The leaf spring is constituted of leaves, okay, that are fastened through a central bolt, and they are also held together by clips, which we can observe here, right. So, we can observe that there are clips which are holding the leaves together. Now, we can see that these clamps attach the leaf spring to the axle when we come to rigid axle suspensions with the leaf springs, we will see more details on how they are attached, to the axle, and as the wheel assembly moves up and down, because the wheels are fixed to the axle, right. As the wheels are displaced, what is going to happen is that the wheels are, these leaves of this leaf spring are going to deform and absorb the energy, like that is coming in due to the these vibrations. Okay. So, the main advantages of these leaf springs are that they are simple in design, we can have multiple leaves to make it stiffer, okay, and pretty easy to operate, okay, and install and maintain in a vehicle, right. But there are some limitations. Limitations are that they are heavy, they can weaken with time, and due to the mass, they are susceptible to sag. Okay. So, the effectiveness of the leaf spring goes down with time. Okay. So, that is an limitation of leaf springs. Okay. So, this is one common type of springs which have been around for a long time and still quite popular, right. So, the second type of energy absorbing element is what is called as a torsion bar. So, what is a torsion bar? Okay. So, a torsion bar, as the name indicates, essentially is a structure, like which will ensure that energy is stored in it when it is twisted. So, let us look at what happens in a torsion bar. Okay. So, this schematic provides a simple representation of a torsion bar. What happens is that this is the torsion bar, as we can observe. So, one end of the torsion bar is connected to the suspension arm. So, as the wheel travels up and down, the suspension arm is going to act like a lever, right. So, because this is going to travel up and down. So, what will happen? The other end of this torsion bar is fixed to the vehicle frame. So, this motion is going to twist the torsion bar, and the torsion bar has a torsional stiffness, right, through which it stores the energy coming in due to the vibrations. Okay. So, that is the simple realization of a torsion bar. Okay. So, a torsion bar essentially consists of a steel rod that is attached to the vehicle body at one end, the other end of the torsion bar is attached to a suspension component. Okay. Typically something like what is called as a control arm, okay, and that acts as a lever, right. So, as the wheel travels up and down and undergoes a vertical motion, the vertical motion is going to be converted to a twist of the torsion bar, right. So, the vertical motion of the wheel assembly results in a twist of the torsion bar, which essentially results in storing the energy, right. So, that is, and some torsional stiffness is provided to the suspension system, right. So, the main advantage of this is that this is durable and takes very little space, right, particularly in terms of volume and also along the width of the vehicle body, right. So, that is a big advantage, but one limitation is that the effective spring rate or the effective spring constant or the stiffness, or let me call it a stiffness, okay, is difficult to adjust. Okay, suppose we want a certain stiffness level, no, it can be done, but it is challenging. Okay, there are better solutions to do that. So, but this certainly an option, right. So, moving on, the most common spring that is used today, like in road vehicles, is the coil spring. So, what is this coil spring? So, let us look at coil springs next. So, a coil spring is nothing but a metal rod that is, or bar, which is essentially wound up in a coil, right. So, that is essentially a coil spring. So, as we can see, a coil spring is nothing but a steel rod or bar that is wrapped into a coil. Okay, so, that is a coil spring, right, as we can observe here. It is the most common type of spring and that we have always been exposed to, right. So, the main advantage is that they are compact, right, and they are pretty what to say, we can essentially get the desired spring rate or the stiffness, right, by designing the coil spring carefully. Okay. So, that is an important advantage, but then please note that the coil spring is going to provide support only along its axis. So, it is very compact and consequently used where space requirement is a constraint or space availability is a constraint. However, the coil spring will provide support to the suspension and to the vehicle body only along its axis. Consequently, they require additional suspension elements, okay, which we will encounter as we go along, right. So, additional elements to provide support to the suspension along the lateral and longitudinal directions. See, at a very broad level, one can think of a suspension as something like which connects the wheel assembly, the axle to the vehicle body. So, that is a connection, right. So, when we are connecting it, like it should provide some support, some compliance along all the axes, not only the vertical, but also longitudinal and lateral axis, right, and try to serve multiple purposes. It should dampen out the vibration levels along the vertical axis to result in good ride comfort, but also at the same time it should try to minimize motions along the other axis like pitch, roll and so on, right. So, there are multiple requirements. So, we have other elements to take care of these requirements along with the coil spring, okay, the way it is realized, okay, along the lateral and longitudinal directions. Okay. So, coil springs are quite popular, right. So, now today if we look at heavy trucks and buses, right. So, the most common energy absorbing element which is used is what is called as an air spring or a pneumatic spring. Okay. So, such suspensions are commonly called as air suspensions. So, what is this air suspension? Okay. So, an air suspension essentially uses the compressibility of air, right. So, it makes use of the fact that air is a compressible fluid and uses that fact to absorb the energy, right, when we have vibrations, right, in the wheel assembly and the vehicle body. So, what happens is that like we have what is called as an airbag or a bellow like which is filled with compressed air, and that is placed between, one can see that the axle and the chassis or the vehicle frame, right. So, as the axle vibrates, like due to the vibration of the wheels, this air, compressed air in the bellow takes up the vibrations, right, absorbs the vibrations because of the compressible nature of the fluid, which is working fluid, which is air. Okay. So, currently used, very commonly found in trucks and buses, they use the compressibility of air to absorb vibrations. So, typically what we have is that, like, we have the entire system, right, consists of a compressor. Of course, we need air supply, we need a storage reservoir, but now we can understand why it is popular in trucks and buses, because as we already discussed, in a truck and a bus already we have a storage of or availability of compressed air. Why? Because we have an air brake system. So, this makes a natural fit there, right. So, we already have a source of compressed air. So, we need we need control valves, right, control system, and a rubber cylinder or bellow, or what is called as this airbag. Okay. So, here in the schematic. Okay. So, that is what, and such a system also is amenable to real time control. So, which has led to what is called as an electronically controlled air suspension. Okay. So, today there are vehicles with this so called ECAS systems, okay, electronically controlled air suspension. So, what happens in this electronically controlled air suspensions? The air pressure is modulated to regulate the deflection, the suspension deflection, right, and the suspension performance. Okay. So, for example, some common like users of this system is to provide what is called as a self leveling action. So, what is self leveling? Suppose like we are, the truck or a bus is traveling on uneven roads and there are changes in the loads, as we discussed, from fully laden to fully unladen, but we want a constant ground clearance or what is called as a ride height. Okay. This air suspension can adjust the suspension deflection to maintain a constant ride height. Okay. So, that action is what is called as self leveling. Okay. Self leveling essentially implies that a constant, an almost constant ride height or ground clearance of the vehicle above the road is maintained, okay, even with changes in load. Okay. So, that is an important function. Another function is that it can help in lowering the vehicle body, particularly when we are doing high speed driving. See, for example, we have high speed buses, right. So, if the roads are pretty good, we are going on nice highways at nice roads at high speeds. So, this air suspension can also be used to reduce the body height. Why? Because as we know, when we corner, there is going to be significant roll, and reducing the height lowers the CG location also. That will result in better roll stability, right. We can also have rising of the vehicle body, particularly when we go on off road operation. Let us say we have mining trucks and so on, right, where the road itself is going to be very uneven. So, we want to, we are anyway going to go slow and there is anyway going to be significant road, right. So, then what happens is that like we want to increase the ground clearance a little bit, so that like we have space between the uneven road and the components of the vehicle, right. So, one could also have this rising functionality using in off road conditions. Okay. So, that is a broad discussion of air suspension. So, these are some common springs or energy storage elements that are used. So, we would continue in the next class and look at shock absorbers and other components of suspension. Okay. Thank you.